Who's got some, anybody got some homework questions? Start with some of those if you got any.
What? Cool question.
Homework questions? Nah? Okay. Fair enough. If you change your mind, holler at me. Today, I'm gonna pose the question. If we have two different investment options that have different interest rates and different compounding periods, how can we tell which one is better and like how much better, right? So let's look at kind of a specific example here, and we'll kind of talk about what we can do. So here it says you have an account that has 6.5% annual interest rate, compounded monthly. And we're asked, what would the equivalent interest rate be for an account that's compounded annually? So like, what would be a comparable deal, right? So here's the idea, what we would do. So if we're talking about the compounded monthly one, we could write the equation like that. If we're compounded annually or yearly with an unknown interest rate, we could write that. Now, if I notice everything other than these pieces that I'm kind of like setting apart in blue are identical, right? What does that tell me? It tells me that if I want to find the value of R that makes it equal to that, right? So all I got to do now is solve this equation for R. So I'm going to subtract 1 over and multiply by 100. And I get about 6.97. That's not right. What did I say there? 6.697. That's more like it. So that would be what the annual interest rate would have to be for these two investments to be equal, right? So this idea of taking an interest rate that's compounded some amount and translating it into an equivalent interest rate for an annual compound gets a special name. This is the APY, annual percent yield, or in the case of a loan, I think it's the APR, annual percent rate. So you might see that advertised on commercials for cars or whatever, people advertising the APR. Now, likely the loan is like a monthly compound, but when you compare loans, you compare APRs, right? You just translate everything to what the percentage it would be for a monthly or for a yearly compound. So it makes it easy to compare to loans or to investments or whatever. So let's just take another example here. So let's say we have two investment opportunities, one that pays 7.8%. You can find it? Do one of you hoodlums have his tablet? Did one of you two hoodlums hide his tablet? If he closes his eyes and turns around and it appears on his desk, he'll be happy and not say anything.
He checks his backpack.
Maybe they moved it into a different pocket of your backpack that you didn't expect it to be in. Now I'm... Oh my goodness.
It's a miracle.
That seems unlikely, doesn't it? All right. So here it says, we're asked which savings account is better, one that pays 7.8% compounded quarterly, or one that pays 7.6% compounded weekly. So what we'll do here is we'll just calculate the APY for each of them. And we'll just work this out on the calculator. So that first one is 803. That's the equivalent yearly interest rate for the same situation. And the other one is 794. So which one is the preferred investment? The one with the bigger interest rate, right? If these were loans, you'd want the one with the lower interest rate. And how much better is the quarterly deal than the weekly? About 0.1% better, right? Everybody's feel okay there? Not a big deal. The next idea that we want to talk about is an annuity. So let's put in the definition for an annuity. So an annuity is an account into which a sequence of payments are made. So you can imagine if you have like a retirement savings account where you're putting in like $100 every paycheck, or even if you think about the reverse idea, if you've borrowed money, you've taken a loan out, the monthly payments that you make to pay back the loan are typically the same amount every month. You know, if you buy a car and it's, you know, you're paying $500 a month for your car payment or whatever. That's the idea here. When the payments are always the same amount, we call this an ordinary annuity. Typically, everything you deal with commonly is going to be an ordinary annuity. Most people save the same amount of money every month for retirement, or pay the same make the same loan payment for their car, or their house, or whatever. So the future value of an annuity is the value of that annuity, that investment in the future. PMT is the size of that ordinary payment. So whether you're making $500 a month or $2,000 a month or whatever you're saving. I is R over 100K, where R is the interest rate and K is the number of compounds per period. And N, cap N, is K times N, so it's the compounding periods times the number of years. So it's really like the total number of payments that you have to make, right? So let's take a look at a numeric example here. So at the end of each quarter, Sarah makes a $500 payment into an annuity account. Again, we see annuity account, so I know the formula I'm using. If her investment earns 7.88% interest compounded quarterly, what will the value of the annuity be in 20 years? So that 20 is my lowercase n. The 7.88% is my R. Quarterly tells me my K is 4. 500 is my PMT. So if I just go and plug this stuff now all into my formula. Remember, lowercase I is just the interest rate R over 100 times K. And then N is N time, lowercase n times K. So that's what I'm going to be typing into my calculator. Now that's a spicy meatball of a thing going on in there. What I'm going to do is I'm going to type in that lowercase I separately. So I'm going to do the 7.88 over 100 times 4. I'm going to take that number and store it into a variable. So I press this STO button down on the bottom here. And then I'm going to use the letter I, so I'll use alpha squared. So that's my I. So now I'm going to do 500 times fraction 1 plus, and then instead of writing this as another fraction, I'm just going to use that I that I just made to the 20 times 4. Minus 1 over I. So I get $95,483.39. Which is not bad. The other way in which we might want to use an annuity is if we are borrowing money, we might want to calculate the, we want to be able to calculate the monthly payment and then analyze what's going on with our loan. So if we're doing it in that direction, we look at this equation where PV is the present value, or that's basically the amount of money you're borrowing via loan. The PMT is the loan payment that you're going to be making. I is still that R over 100K. Cap N is still K times lowercase n. So it's very similar to the same formula as before. But this time it's for a loan situation rather than an investment situation. So if you're borrowing money, you're going to be using that formula, this formula we just worked with. If you're investing money, you'd use the previous formula we just made, or just looked at, excuse me. All right. So Maria buys a new car for $18,500. Their monthly payments, so that tells me K is 12. For a 4-year loan, so that tells me N is, lowercase n is 4. If she makes $2,000 down payment and the annual interest rate, that tells me the R, is 2.9%. What are the monthly payments? So I'm going to be using that PV equals PMT formula from above. The piece that I don't have yet is the PV, right? Which is the amount of money that I've borrowed. How much money is Maria planning on borrowing? The car costs $18,500, and we're going to make a $2,000 down payment. So everything left over is going to be what we need to borrow. Everybody okay with that idea? The PMT is what we're solving for. And again, I'm going to do this the same way as I did the previous one, where I'm going to calculate that value for lowercase I in advance. And I'm going to store that again as a variable. And the variable I'm going to use again is that uppercase I. So what I'm going to do is I'm going to divide all of this to both sides. So I'll have 16,500 divided by this side. I'm going to calculate this side separately though, and then just kind of do the ants on it. So I have 1 minus, parenthesis 1 plus that I, where'd it go? There it is. To the 12 times 4 over I. So that's that. Oh my goodness, guys. Look at how silly am I. I forgot the negative sign. It's like that number should not be negative. Silly Mr. Kulik. Okay, there we go. And then I'm just going to take the 16,500 and divide both sides by that. So my loan is about $364.49. So for $364.49 every month, Maria can walk away the proud owner of a new car, whatever that car is, probably a Toyota Corolla or something. I'm just making jokes. I don't really mean, it's like the most common car in the world, and it's relatively inexpensive based on the $18,000 price point. All right, so the next question that should come up is, okay, so that's what I'm paying every month. How much did I end up paying for that car in totality, right? So what did I end up paying for the car? Well, I put $2,000 down that I paid right away. And then I paid $364.49 every 12 months for 4 years. So that'll be the total cost of my car. So I do that and I get $19,495.52. How much did we pay for the loan? Well, that was just the payments, right? So how much did we pay in interest then? It's just going to be the cost of the loan minus the amount borrowed, aka the PV. So when we do that, we get about 995.52, which, as far as a loan for a car goes, that's not too bad to only pay about $1,000 over the course of 4 years in interest. 2.9 is a pretty low APR to get. Actually, that's not an APR because it's monthly, but that's a pretty good loan rate. Good luck getting that these days. Plus, you probably didn't have to pay over MSR, which seems like that's what you're doing these days also. Anyways, enough about the economy. At this point, though, we have finished Chapter 15. So the new homeworks you should be able to do from 151 to 184. So that's going to be due not this Sunday, but the following Sunday. Well, we might as well say the review. We'll work on the review on Monday. That'll be our review day. For this weekend, I think, what do we have? We had assigned 131 to 138 already. And then last time we did like 139 to 150. So that'll be the assignment for Sunday. And tentatively scheduled for Wednesday next week will be the Chapter 15 test. If you didn't notice, and I don't know why you would have because I just did it a moment ago, but I dropped in the 15 review. We'll have time to work on that again on Monday, and I'll talk about the test format and all that again on Monday, and we'll make our half sheets and all that jazz on Monday. But just figured I'd give you the heads up a couple days in advance. I know it's been a hectic couple of weeks, so some of us still have a lot of catching up to do, so giving some forewarning on all this stuff probably helps quite a bit. Questions for me about any of that kind of stuff? You guys are so talkative today. I'm just joking. You guys are so talkative every day. So yeah, that's a wrap on this.